Great. Well, thank you everybody today for coming to the Resource Code Toolbox launch. It is basically the last event of the Resource Code project, of which I'll give a bit of an overview, and it's an opportunity for us to talk about some of the work that's been done and some of the deliverables and the outcomes that have been achieved. Before we get into the agenda, can I just quickly ask people who are on the call just to make sure that cameras are turned off, videos turned off, and also audio as well. I don't know if that's done automatically, but just in case it isn't, just to be aware of the bandwidth. So let's get started. This is the agenda. I shall be beginning with a very quick overview of the project, talking through a little bit of the background and the high level side. And then we shall jump into the interesting stuff. Mikhail will be talking about the Resource Code Marine Database from IFRMA, and Nicola, also from IFRMA, will be doing a live demonstration of the toolbox as well, and that will form the sort of the meat of the day. And then at the end, we'll have a good half an hour for sort of questions, answers, and general discussions as well. So what I would ask is that there's a feature on the program that will allow you to put in questions as we go through, and it would be great if people could be writing questions in as the various presentations go through, so we can pick those up again at the end. It also gives us a bit more time as well to formulate some good responses, so we get the most value out of it. So yeah, without something else, I'll jump into the presentation. So the Resource Code project, we started now around 3 years ago. It is funded by Ocean Energy IRINET co-fund. So that's basically an organisation existing across a number of different countries in Europe, where it sort of enables partnerships, but also the individual partners are funded locally. So for instance, in EMEC's case, so we're a Scottish marine test site. We're funded by Scottish Enterprise, the French partners, for instance, and the Irish partners will have their own local funders. But it's really good at sort of promoting international collaboration. And the Resource Code project will go through the different partners, but it was led by EMEC, who I work for as a hydrogen development manager and project manager as well. So the principal aim of the Resource project is to create a integrated marine data toolbox for developers, people who work within ocean energy in general, and people who work with devices and arrays and suppliers. And the idea is to allow and optimize key technical decisions to be made using the tool. As I said, it's got an international consortium, of which I'll go through individually on the next slide, but it's been a really effective way of being able to work actually in partnership across Europe, and a really good model, hopefully, for future projects. We've been working for around 3 years now. Obviously, the COVID has got in the way to some degree, and we haven't quite been able to meet as many times as we'd hoped physically, but it's been very good working as partnerships anyway, remotely. And we're now nearing the end of the project, as I said, and this will be the final thing that we do, which is the actual release of our final toolbox. So the Resource Code Consortium, the people involved, drawn from across Europe. We have ourselves, the European Marine Energy Centre. As I said, we're a Scottish-based marine test organisation. We have École Centrale Nantes, who are a French school specialising particularly in engineering. We have Ocean Data Lab, who are the data and technology sides, bringing that to bear on the project. University College Dublin, who are one of our key academic partners. We have Blue Wise Marine, who are an Irish developer and specialist in marine energy. Innocy, who are an engineering consultancy based in France. IFRMA, who are the French society of French Marine Society, and the University of Edinburgh are other key academic partners. So as you can see, a pretty broad skill set, both in the private, sort of semi-private commercial such as ourselves, but also in the academic as well. And there's a photograph on the top right of the team right at the beginning of the project, although I know quite a few changes since then. In terms of what the project has delivered, so it can be broken down principally into two pieces, although obviously a number of specific things that fall underneath those. So first and foremost, we have a calibrated, verified hindcast data set, which is measured data over the previous 27 years for wave data and a few other things as well, which exists at the core of the project and basically provides the basis of which everything else has been done from. And then there's the front, so the front piece of that is a toolbox, which allows that data set to be accessed, bringing the information into a forum where you can quickly and easily make some key calculations and use it for decision making. The product itself is based in Western Europe, so the area which you see in that image is where the HiCast data set exists, and it's aimed at a combination of developers and academic and technical specialists, and really anyone within the industry who is looking for this sort of data around example waveflights, for instance. And in terms of what we're trying to achieve for the industry, and I'm sure we will, there's a few things. First and foremost, because the data set is the data set and toolbox are open source, it allows open access and increased number of people to actually access and be aware of that data, and that's incredibly valuable. It sort of creates a tool which is available for everyone. That in itself supports a reduction of cost. It means that principally in early design decisions, there is a good basis there for early decision making. Now, obviously, there is further work that will need to be done on top of that, but it reduces that barrier to entry for organisations, particularly if they're wanting to do, cast their net quite wide and make quite a few sort of key calculations and decisions early on before focusing on a particular technology or a particular area. We also believe that what we've done here is very, very reliable. It will be very valuable in reducing uncertainty, which of course is important both in terms of environmental and technical conditions, but actually one area that we've seen as a huge challenge for the sector in general is on the investment side, and this will support the de-risking of investment and will allow investors and designers to make more robust decisions early on, which is incredibly important for the whole industry. Again, we're confident that it'll add quality as well into the industry because it's traceable, validated data, and again supporting high caliber marine engineering development. Sorry. And finally, and it's maybe least tangibly, but I think possibly most importantly, is it generally adds to the knowledge in the industry. We're an industry where we're still quite green, we're still quite new, and actually bringing that additional knowledge, additional information, additional tools into the sector, open source for sharing, is actually incredibly valuable, and we're beginning to see that already. And we've actually widely tested the toolbox with key partners, and we're beginning to see the value of that come out within the sort of write-up of those exercises. So that's it for me, really. I'd just like to say it's the last event of the project. It's been a real pleasure being involved in this project, and I'm handing over to Mikhail from IFRIMA, who's going to start looking at a bit more detail about what I've been through, and then we'll be having the toolbox demonstration as well. So Mikhail, over to you.